So what do we do if the right-hand side does not look like a power of t? Well, we'll look at two examples where we try to find a educated guess just like we did in example 1. So in example 2, we're going to try to find a particular solution to y double prime plus 3y prime plus 2y equals 10e to the power 3t. So now our educated guess is yp of t is some constant times e to the power 3t. Right, so I'm going to say yp of t is a constant times e to the power 3t. All the derivatives will end up with e to the power 3t, so hopefully we can find a so that we end up with a 10 right here. So if that's yp of t, then yp prime of t is 3a e to the power 3t. By chain rule, derivative of 3t gives us a 3 there. And then yp double prime of t gives us 9a e to the power 3t. So now let's copy down that differential equation that we need to solve. So we have yp double prime plus 3yp prime plus 2yp, and that equals 10 e to the power 3t. So now let's plug that in. We have plus 3 plus 2 and y double prime of yp double prime is 9a e to the power 3t plus 3 times 3a e to the power 3t, and then plus 2 times a e to the power 3t, and then that must equal 10 e to the power 3t. So now let's again simplify that sum. Right, so on the left we have 9a plus 9a plus 2a. That's going to give us 20a e to the power 3t, and that should then equal 10 e to the power 3t. Bring that to the other side, and we see that we get 20a minus 10 times e to the power 3t. That has to be 0 for any t. Now, because this can vary, we must then have that the coefficients in front of the e to the power 3t, that has to equal 0. So we have 20a minus 10 equals 0. Bring the 10 to the other side, divide by 20, and we see that a equals 1/2, and that seems to work. So our solution here is yp of t equals e to the power 3t, and then a constant in front of it is 1/2. Now you should verify for yourself that when you plug this into this differential equation that you indeed get a solution. Okay, now let's try another one. Find a particular solution to y double prime plus 3y prime plus 2y equals sine of t. So our first try might be a constant times sine of a. So I'm going to try yp of t equals a sine t. That means that yp prime of t equals a times cosine t, and then yp double prime of t is negative a sine of t. Okay, then what we need to have for our differential equation is the following. Yp double prime plus 3 yp prime plus 2yp equals sine of t. So we have plus 3 and then plus 2, and then that has to equal sine t. And let's plug in what we know. Yp double prime is negative a sine of t. Yp prime is 3 times a cosine t. And then yp is a times sine of t. Okay, let's clean that up a little bit. So we have 2 times a minus a. So that together gives you a sine t, right? Plus 2a minus a gives us a times sine of t plus 3a cosine of t. That equals sine of t. Now let's bring the sine of t to the left, and we have a minus 1 times sine of t plus 3a cosine of t, and that's 0. Now again, we see the right hand side is constant. It's always 0. And here on the left, we have a function of t. And this needs to hold for every t. So again, we get that this is 0, and this must be 0. So simultaneously, we have that a minus 1 has to equal 0, and then also at the same time, 3a equals 0. Well, that's equivalent with a equals 1 and a equals 0. And that clearly is a contradiction. This doesn't work because the derivative introduces a cosine of t, which we cannot get rid of. So now our second try is to introduce that cosine. So the way we're going to introduce that is as follows. We're going to have our educated guess yp of t be a times sine of t plus b times cosine of t. Okay, now that means that yp prime of t is going to be a times cosine t, and then derivative of cosine is negative sine, so we have negative b sine of t, and from that it follows that yp double prime of t is negative a sine of t, and then minus b times cosine of t. Okay, so let's take a look at our differential equation. We have yp double prime plus 3 times yp prime plus 2 times yp has to equal sine of t. And so we start off with our yp double prime, which is our negative a sine of t minus b times cosine of t. And then we have plus 3 times yp prime, right? And so that is a cosine t minus b sine of t. And then plus 2 times yp, right? And that's a sine of t plus b cosine of t. And that whole left-hand side has to equal sine of t. So now let's combine all the signs on the left. So we're going to combine. We have a sine t here, sine t here, a sine t here. So we get negative a, and then plus 3 times negative b is negative a minus 3b, and then 2a, so plus 2a. And that's sine of t, and then the cosine, I have a cosine here, cosine here, cosine here. So we're going to start off with a negative b here, and then plus 3a, and then a plus 2b times cosine t, and that equals sine of t. Okay, now we can simplify this further. Negative a plus 2a, that gives us a minus 3b. And then this is a 1 times sine, so we can take that to the left and we get a minus 3b minus 1 times sine of t. And then the second part, negative b plus 2b, gives us b plus 3a times cosine of t, and that has to equal 0. Now, again, this has to hold for all t. So what we see here is that a minus 3b minus 1 has to equal 0, and we also see that b plus 3a has to equal 0. So the first equation leads to b equals negative 3a. And if I plug that in here, then this equation gives me a minus 3 times b, which is negative 3a, minus 1 equals 0. That's negative 3 times negative 3 is positive 9. So this gives us 10a minus 1 equals 0. And so a equals 1 over 10. And that means b being equal to negative 3 times a, it follows that b equals negative 3 over 10. And so our final particular solution that works is yp of t equals sine t plus cosine t with coefficients 1 over 10, and then plus negative 3 over 10, I can change that into just a minus. And so minus 3 over 10 cosine t. That is our particular solution that works. So if we want to generalize that, we can say that if we have an equation of the form ay double prime plus by prime plus cy equals c times sine beta t, or c times cosine beta t, the method of undetermined coefficients suggests that we guess yp of t is a times cosine beta t plus b sine beta t. So even though the right-hand side only contains one of the two, a sine or a cosine, we still have to include both of them in our educated guess for the particular solution. And then we solve for the unknowns a and b.